Now, the numbers here are simple enough that actually if I really wanted to, I could list this whole thing out, okay? Which we are going to do at the end of this so we can verify that we get the right answer. But of course, it's not that hard to change this to be something that you can't just list out. I could just say do that, and then you'd say, you know, you'd flip the table and go home, okay? So let's just consider this as a simple one enough so that at the end of this we can verify our answer. In order to get to this, what the greatest coefficient is, I need to know what the coefficients are, I need to get to that ratio, and I want to find for which terms is that ratio continually getting bigger, okay? So to start with, let's think about what are the terms, and then let's pull out the coefficient, okay? So for example, what is the kth term of this particular thing? I'll give you a clue. It starts with 5ck. What am I going to write next? What are the extra bits?
1 to the power of k. Wait, sorry, no, 1 to the power of 5 minus k. Okay,
I'm going to pause you there. You might have noticed, maybe you weren't quite paying attention because you were writing your own thing. First, Reynard said this, and then secondly, he said this. Okay, now let's just pause for a moment. Both of those are okay. Can someone tell me why?
Because you can swap it around.
Yeah, okay, so when I'm saying the general term, right, you can start from one end and to walk through, or you can start from the other end and walk the other way. And they both give you the same terms, right? They will still generate the same 6 terms, just you'll write them backwards, okay? Now I'm going to ask you in a second, because it actually does make a minor difference, which one of these is better? If you see it immediately, don't tell me, but think about it, and how would you work out why one is better than the other, okay? Let's just finish it off. Let's try the first one first. So if I write k up here, I've got the binomial coefficient, I've then got this part, however many of them I have. How many of these will I have if I have k of these ones?
5 minus
Okay, good. So I'm going to write it like so. Okay? So I've got that. That's fine. How would I write it the other way?
swap the 2 powers out.
Yeah, that's right. All these have to do is switch around. Okay, so I could write it like this. Okay, now I don't think it's immediately obvious, just at least it wasn't to me when I was learning this, which of these is superior. So what I'm going to do before I, open the veil and spoil it for everyone and for those who have already worked it out, I don't just need term k, right? To actually solve this coefficient thing, I need to compare it to the next one. Yes? Okay, so what I'm going to do is I'm also going to write tk plus 1, and I'm going to write it both ways as well, just so you can see. I hope it becomes a little clearer. Okay, so if I'm going with the first scheme, let's just follow this across. If that's term k, what does term k plus 1 look like? Start with the binomial coefficient.
I choose k plus 1.
There's that bit. And then I'm going to have the next power of 1, which is 1 to the k plus 1. And then I'm going to have the smaller power of this, right? So this is going to be
4 minus k.
3x. Yeah, before I simplify it, I'm going to write it. I'm just going to do a straight substitution. So it's actually 5 take away the new value of r, which in this case is k plus 1. You can see how I've just done a swap. And then I'm going to write it in the other scheme. Okay, so here is my other way of writing tk plus 1. I still have the same binomial coefficient out the front. And then I'll have this guy. Okay. Now, last step before it becomes really clear, I hope, which one of these is better, right? Do I go with option 1 or do I go with option 2, right? What am I going to do with these things? I actually don't need this whole term. There's only a part of it that I need. Which part do I need? Have a look.
The coefficients.
Yeah, I just need the numerical part. I'm not interested in the x's, the variable bit. I need to pull out just the numbers and use those. That's what's going to form my ratio, okay? So let me just underline them for you. Do you see, let's have a look. This is a number. It's just a number, no variables. This is a number. And this part here, the 3, is going to be a number. And then I sort of abandon the x, right? In the same way, I've got this is a number, and this is a number, and then this is a number, and I abandon the x, okay? And once I have those things, right, I'm then going to divide them, and hopefully there will be some funky cancelling that happens that makes things nice and neat. Now have a look, okay? If you were going to choose either this one or this one, you're going to choose either this one or this one. Which do you think is going to be easier to work with and cancel out? The answer is it's option 2. It's this one here. Okay, Okay, let me put a box around it. The reason why it's so much easier to use, and I'm pointing this out and making a big deal out of it because frequently this number will be 1. Not always, but frequently, okay? See how this is like some messy gross power, right? See here? And even this one is not that nice. It doesn't matter. I don't care what that power is because it's just 1. Any power of 1 will always be 1, okay? So immediately I can just ignore him and my cancelling out, my arithmetic becomes subsequently much easier. Whereas if I'm trying to mess with this guy, like I'm asking to make a mistake, right? So therefore, even though I could write it like this, and sometimes you will not have a choice, sometimes both of these numbers will be somewhat messy, okay? When I do have a choice, I'm gonna write it the second way, because in a second, when I pull out the coefficients, the ones will just vanish away.